In part B, we're told that the ball takes 1.3 seconds to reach the wall. We are asked to show that the initial speed of the ball is about 9 meters per second. So what we need to do here is that we know that the velocity here in this diagram is pointing this way, and it will have a x component and a y component. And we know that we can deal with these separately in projectile motion. And we know that there's no acceleration in the x direction, which means that the horizontal speed is going to be constant. And we know that it took 8 meters to travel for 1.3 seconds to the wall. So we can calculate the horizontal speed. So we can say ux, the horizontal component of the speed, is going to be the distance over time. So 8 over 1.3, which will give us 6.2 meters per second. Now we also know that there's an angle of 48 degrees here. So what we can say is that this cosine 48 is equal to adjacent over hypotenuse. So the adjacent side is ux, and the hypotenuse is simply our speed. So from this, we will find that the speed is 9.2 meters per second, which is what we had to show. And in part 2 of B, we need to find the height, the height above which the ball hits the wall. So now we have found the initial speed of the ball, so we can also find the vertical component of the velocity. So we can find uy. The vertical component is simply u times the sine of the angle. So 9 times sine of 48 degrees will give us 6.84 meters. And we can use s is equal to ut plus 1/2 at squared to find its displacement in the y direction. So our initial speed in the y direction is 6.84. The time is 1.3 seconds. To this we add 1/2 times our acceleration times our time squared. So if we plug this into our calculator, we get 0.603 meters. However, what the question asks is the height above the ground at which the ball hits the wall. So this height we found is simply this height over here, as we took this as our initial height. However, the person is 1.8 meters high, so the height h will have to be the 0.603 plus the 1.8 initial height, which will give us approximately 2.4 meters.